Deep in the Amazon basin, where humidity hung thick enough to taste, a French botanist pushed through a curtain of vines, his eyes fixed not on the towering canopy, but on the forest floor, where a splash of crimson and emerald fanned out from the damp soil. He knelt, brushing soil from the broad, heart-shaped leaf of a plant the locals called Caladium, and carefully sliced a specimen for his collection. The leaf's vibrant veins promised ornamental beauty, a treasure for European glasshouses. Weeks later, aboard a ship creaking across the Atlantic, the botanist stored his pressed leaves between sheets of dry paper. He catalogued them simply as foliage of remarkable coloration, noting their resemblance to the ears of an elephant. In his journal, he speculated on their potential to thrive in shaded conservatories, completely unaware that within the cellular flesh of his prize, millions of microscopic daggers lay dormant, a silent defense evolved over millennia. The specimens finally arrived in Paris, their colors still startlingly vivid under the grey northern light. Curious horticulturists propagated the exotic plants, marveling at how their leaves could brighten a dim corner. They handled the roots and stems with bare hands, feeling nothing but smooth plant tissue. None could have imagined that a single curious bite would release a storm of invisible needles, each sharp enough to tear into the soft flesh of a mouth or throat. Back in Europe, the pressed leaves from those tropical expeditions found their way into the dry, warm air of a botanical greenhouse. There, a curious botanist selected one of the vibrant Caladium specimens, flattening a small section beneath the brass tube of his early microscope. He adjusted the lens, bringing the leaf's inner world into a blurry, then startlingly sharp focus. His breath caught. The plant's tissue was packed with dense bundles of needle-like structures, each one a crystalline spear. He carefully sketched what he saw, his pen tracing the forms he called raphides. They were not smooth rods, but jagged, resembling minute shards of glass purposefully manufactured by the leaf itself for defense. This was no chemical venom, but a physical arsenal. The botanist realized these microscopic crystals were designed to be released when the leaf was crushed or chewed. Their sharp edges could lacerate soft membranes on contact, explaining the immediate, violent pain reported by those who had tasted the plant. The beautiful leaf hid a forest of tiny blades. Back in London, the pressed leaf and its microscopic sketch found their way from the botanist's study to a physician's consulting room. There, a patient sat clutching his throat, his words strained and thick. Between gasps, he described reaching for what he thought was a decorative leaf, placing it between his teeth, and feeling an immediate searing fire erupt across his tongue and gums. The physician examined the man's mouth, noting the angry red swelling and the tiny, almost invisible punctures on the soft palate. He listened as the patient gestured wildly toward his parlour, describing the large, heart-shaped leaves with vivid veins. The doctor's mind connected the dots. The patient's description matched the very specimen, a Caladium, whose botanical illustration had recently circulated among his colleagues. He sent an assistant to the patient's home, who returned with a leaf from the potted plant. Holding it carefully, the physician understood. This was no chemical toxin, but a physical assault. Those microscopic glass-like needles, the raphides sketched by the botanist, had been embedded in the man's flesh upon chewing, causing the violent localized reaction that mimicked a poisoning. The physician's clinical observations in London had identified the culprit plant, but the precise mechanism of injury remained a mystery. Decades later, in a university laboratory, a chemist uncorked a vial containing a milky sap extracted from a Caladium leaf. His goal was to isolate the toxic agent, to move from correlation to definitive cause. He carefully filtered the sap, then evaporated the liquid under a gentle heat. What remained was a fine, gritty, white powder. Under a standard light microscope, the powder resolved into thousands of needle-like structures, rhaphides of calcium oxalate. They were not a soluble poison, but a physical one, microscopic shards of crystalline glass manufactured by the plant itself. To demonstrate their action, the chemist suspended the crystals in a saline solution and placed a drop on a slide with a thin membrane of animal tissue. Peering through the eyepiece, he watched as the sharp, barbed rhaphides embedded themselves into the soft cells upon contact. This was the violent mechanical truth behind the burning and swelling, 1,000 tiny punctures. The physician's clinical notes from London had travelled far. Decades later, in a brightly lit room lined with monitors, a poison control operator's phone trilled. A mother's voice, tight with panic, crackled through the receiver. Her toddler had just taken a bite from a large, colourful houseplant leaf. "Elephant ear," she gasped, describing the decorative pot in her living room. The operator's fingers flew across a keyboard, pulling up a digital database. The entry for Caladium bicolor flashed on screen. It confirmed the immediate threat, calcium oxalate rhaphides. Her voice remained calm, a practiced anchor in the storm. "I need you to get to the sink right now," she instructed, reading the protocol verbatim from the manual open beside her. "Use cool water and have your child rinse their mouth thoroughly," she continued, explaining that the action would help dislodge the microscopic glass-like needles. The goal was to flush the physical crystals from the soft tissue of the mouth, to stop the burning and prevent more from being swallowed. On the other end, the sound of running water mixed with a child's distressed cries. The poison control operator's calm instructions had stabilized the immediate crisis, but the question remained, why did a simple plant bite trigger such a violent reaction? In a clinical teaching room, a toxicologist lifted a translucent model of the human throat from her desk. Her fingers traced the path from mouth to esophagus, where the real drama unfolded on a microscopic scale. She produced a vial containing a milky suspension. "This is a slurry from the plant's tissue," she explained, tilting it so fine sediment swirled. "Within this are millions of calcium oxalate rhaphides." Using a dropper, she placed a single bead of the liquid onto a glass slide, her movements precise. Under the projected microscope image, the liquid transformed into a forest of needle-sharp crystals. Pointing to the throat model, she described the assault. "These are not chemicals, but physical weapons. Upon chewing, they fire into the soft tissue of the mouth and throat like microscopic darts." She mimed the action with her hands. Each crystal creates a tiny wound, triggering a localized flood of inflammatory fluids. That swelling generates the terrifying sensation of the throat closing, a brilliant, painful warning system that usually spares the airway itself. The toxicologist's clinical explanation gave way to the humid, earthy air of a commercial plant nursery. Under the shade cloth, a worker in thick gardening gloves lifted a potted caladium, its heart-shaped leaves splashed with vibrant pink and green. He turned to a curious customer, admiring the display. "They call them elephant ears for their size," he began, his voice carrying the practiced tone of daily warnings. His gloved fingers traced the edge of a leaf without touching its surface. But every part of this beauty, stem, leaf, even the roots, is packed with microscopic needles. He described the calcium oxalate crystals as nature's own fiberglass, designed to shred the soft tissues of any mouth that tried to take a bite. The customer's smile faded as she took a half step back from the lush foliage. The worker gently returned the plant to its bench, his movement deliberate. "So we always say, admire with your eyes, not your teeth. Keep them up high, away from kids and pets." It was a simple, physical rule, born from centuries of painful discovery. turning a moment of botanical appreciation into one of grounded respect for a plant that fought back with geometry, not chemistry. The nursery workers' warning about Caladium echoed as the scene shifted to a humid glasshouse in a major botanical garden. A horticulturist in a sun-faded shirt knelt beside a lush display, his gloved finger tracing the prominent veins of a Caladium leaf. He then gestured to a nearby Dieffenbachia, its broad leaves dappled with cream and green, and finally to a towering philodendron climbing a moss pole. "Look at this family," he said to a small tour group, his voice carrying over the drip of irrigation systems. "Different shapes, different patterns, but they're all cousins in this botanical arms race." He plucked a single damaged leaf from a specimen plant, holding it carefully to the light. "Herbivores, insects, mammals, see a tasty meal, but bite down and you're not getting a chemical toxin. You're getting a mouthful of microscopic needles." He described how, millions of years ago, these plants in the Araceae family all evolved the same brutal solution. Their cells pack calcium and oxalic acid into crystalline raphides, forming a natural arsenal of sharp, insoluble shards that act like fiberglass on a cellular scale. The defense was purely mechanical, he explained, a physical barrier rather than a poisonous one. When an animal's teeth crushed the leaf, specialized cells called idioblasts ruptured under pressure. They fired their crystalline payload into the soft tissues of the mouth and throat. The immediate, searing pain and swelling were the plant's message, broadcast in a universal language of discomfort. It was a brilliantly simple strategy. Deter the eater with sheer abrasive agony, forcing them to spit it out and remember never to try again. The horticulturist's comparison of Caladium to its relatives had revealed a shared defense system, but it was in the sterile quiet of a materials science laboratory that the true elegance of that defense became visible. A researcher in a white coat positioned a prepared sample beneath the massive column of a scanning electron microscope. With gloved hands, she adjusted the controls, bringing into focus what no botanist of the 18th or 19th century could have truly seen. On the monitor, the plant tissue dissolved into a landscape of alien architecture. Nestled within the cells were bundles of raphides, their crystalline forms magnified thousands of times. They were not simple needles, but intricate spears, each one honed to a vicious point. The image revealed microscopic barbs and serrations along their lengths, a texture designed for maximum anchorage. This was a weapon engineered not in a factory, but by evolution itself. The scientist traced a finger across the screen, following the path a single crystal would take. When chewed, these bundles explosively release their contents. Each barbed raphide acts like a microscopic harpoon, punching through the soft membranes of the mouth and throat. The injury is purely mechanical, but it creates thousands of tiny entry wounds. Through these punctures, other plant compounds flood the tissue, triggering the immediate fiery pain and swelling that had baffled physicians and panicked parents for centuries. Back at the Poison Control Center, the operator closed the file on the latest Caladium call. Her logbook lay open on the desk, its pages filled with similar entries from across the region. Each case followed the same pattern. A panicked call, a description of burning and swelling, and then reassurance. The notes revealed a curious truth. These dramatic incidents almost never escalated to true emergencies. She flipped through the records, her finger tracing dates and outcomes. Dozens of reports involved children who had taken a curious bite. Symptoms peaked within minutes. The intense pain, the alarming sensation of a tightening throat. Yet by the time a follow-up call was made hours later, parents reported the swelling had already receded. The painful defense had done its job, then faded. The final entry for the day was logged with a simple notation: mouth rinsed with cool water, Symptoms resolved within 3 hours, no further action required. The plant's microscopic arsenal was brutally effective at delivering a sharp, unforgettable warning. But its design was for deterrence, not destruction. A defense that caused temporary agony but consistently spared lives.